Solar power has been a great help so far and becomes a solid alternative to fossil fuels as a renewable energy. However, it has its own problems. Solar panels depend on the weather. They don't work at night and they take up a lot of space. But what if we moved our solar panels to space so that way they would power the Earth from there? Let's let our imagination roam free for a moment. Picture this: a giant satellite with lots of solar panels on the Earth's orbit. They could be illuminated literally 24 hours a day and produce at least twice as much power than they would do on the ground. We could send this energy back to Earth. The technologies for this already exist. Scientists have been trying out lasers and microwaves to transmit the energy wirelessly. In theory, this satellite or station could point a laser beam to any location on Earth and it'd get powered. Just imagine the possibilities. Remote settlements, for example, in the Arctic or Antarctic could really benefit from this kind of power support. Places hit by natural disasters could instantly be powered from orbit, which could save the lives of lots of people. But then again, how safe would it be to have a gigantic power satellite hanging there? Wouldn't it be like a Death Star from Star Wars with a bunch of lasers that can target anything on the surface? What if the war started? Which country would use it and how? What if the controls went into the wrong hands? Yeah, this would be a very different world to live in. Okay, but seriously, was there ever a real project for a satellite with solar panels? Not a crazy station with deadly lasers, but something more simple and realistic? Actually, the idea of moving solar panels into space for our needs is pretty old at that point. So-called space-based solar power projects have been researched since the 1970s. Here's how a real serious idea looks like. We start by putting a satellite with many solar panels in our orbit. It would be extremely difficult and cost to build it on Earth and then launch it. That's why the satellite would be made out of smaller modules and assembled by robots in space. We would then send the energy from the planets to Earth by using either lasers or microwaves in the form of coherent beams. To harvest this energy, we would build a receiver on Earth, and it would look like a field covered with metal sticks or giant fish nets. The receiver would convert microwaves into energy, and then it's ready for use. That's the actual idea in a nutshell. Well, it's been 50 years since the first projects were developed, so why haven't we done it yet? Because so far, none of them are economically viable. Let's talk about expenses and problems that all these projects face. The biggest problem with solar panels in space is the power transfer. Obviously, engineers don't even consider a cable from space to Earth. But what about those wireless options that I mentioned earlier? Well, the technology is there, but it has a lot of issues. Let's talk about lasers for a second. First of all, lasers aren't efficient. They're not completely safe as well. What's more, they have a hard time penetrating clouds, just like natural light does. That's why today, we lean towards microwave as a primary option. Here, the main problem is power loss. First, the microwaves will have to travel from space to Earth. Then, you'll have to convert them back to electricity. And in the end, only a small fraction of energy generated in space would ever reach the Earth. When Elon Musk in 2012 had called the idea of space-based solar power systems, quote, the stupidest thing ever, he pointed specifically at the conversion efficiency problem. Here you could say, hold up, isn't it super dangerous to have all these lasers and microwaves beams pointing at the Earth all at the same time? So far, scientists don't see any space solar projects as dangerous for people. Lasers might be harmful for the skin and eyes, though they're nothing like the Death Star weapon itself. The microwave beams should be completely harmless. Scientists state that it's going to be even less intense than natural sunlight on a summer afternoon. We will study the effects of microwaves on wildlife and bird life in particular, but so far, there's no reason to claim that our satellite can be as dangerous for people in that regard. Let's go back to the project. The second problem that it faces is the number and the cost of space flights, which consists of two parts. First was the weight of the solar panel. The heavier that something is, the more power and more money that you will need to take it into space. For instance, a couple of years ago, SpaceX paid around $2,500 per pound to bring the cargo to low Earth orbit using Falcon 9. Panels were heavy back in the day, but this we sort of overcame just recently by developing ultra-light solar cells. In 2017, engineers at the California Institute of Technology had presented a prototype that weighed just 280 grams per square meter. There is, however, a second part to the problem. We've already mentioned that our solar station will be built of smaller modules, but one module can't carry too much solar power, maybe 10 megawatts if we're very optimistic. That means that we would need lots of modules and lots of space launches to build a truly powerful system that would be able to make a difference. Space shuttles are also not reusable yet. Each launch is a one-way trip, which makes building a station so much more expensive. SpaceX is currently working on a fully reusable Starship system, but until they truly succeed, taking anything to space remains expensive. But fine, let's suppose we've managed to bring the module to orbit. We somehow assemble the satellite. It's working and we're now sending power to Earth. Here's another question. How long will it last? Space is a harsh place. There's a lot of debris and small meteorites that can easily crash into our satellite and break it. If, or well, rather when, something breaks down, then who's going to fix it? Solar radiation will also degrade the panels much faster than on Earth. The panels in space will lose around 5 to 10% of their power every year. And all things considered, it'll be super expensive to maintain and repair a solar satellite. Even if we set all these problems aside, what do we actually get from a space-based solar system? Well, imagine that we do have a PV system that produces twice as much energy than it would on Earth. Plus, we can point our microwave beam to any location on Earth and send power there, assuming that there's a receiver for it. Yes, we probably could sell this energy to people in need for higher rates than usual, but in no way we would be able to cover our expenses with it and compete with solar panels on Earth. When you put all of this together, the idea of space solar power seems to be a pipe dream, at least for now. The profits, whatever they may be, cannot compare to the costs. So why even talk about it? Well, despite everything, the projects are still being developed by Japan, China, Russia, India, and the UK, along with the US. China, for instance, plans to generate 1 megawatt of solar power in space by 2030 and to have a commercially viable space solar panel by 2050. So, what do advocates of these projects say? For starters, space launches are getting cheaper. The cost of taking 1 kilogram of cargo today is 4 times cheaper compared to that at the beginning of the 2000s. The dynamic is positive, although it's not at the level to justify bringing solar panels into space. The second argument is that our energy needs to continue to grow. By 2050, the demand for energy is going to increase by 50%. Some countries just can't rely on fossil fuels anymore, nor have they enough land for ground-based solar plants. That's why, for example, the UK government looks at space-based solar power as one of the possible ways to achieve net zero. From this perspective, the space solar power projects aren't meant to be profitable. Instead, some scientists believe that they're simply necessary in order to satisfy the ever-growing energy consumption of humans. As you can see, the subject of solar panels in space does have a lot in itself to talk about. The idea is cool, but we aren't there to make it work just yet. How do you feel about making an orbital solar plant? Let us know in the comment section below, and until then guys, that's all for this video. We'll see you in the next one.